Probably the most important convergence test that you'll learn in this class is the ratio test. It comes up most frequently in applications and in other classes. So here's how it works. If you have a series, which is the sum of an, then you look at the limit as n goes to infinity of the absolute value of an plus 1 divided by the absolute value of an. So that means you're looking at the absolute value of a term in the series divided by the absolute value of the term that came before it, and looking at the limit of that. If this limit is less than 1, then the ratio test says that the series converges. If this limit is greater than 1, then the ratio test says that the series diverges. And then there is a third case that's important to remember, which is if the limit is 1, then, who knows? In this case, the test fails, and you just try something else. Okay, so before I explain why this test works, let me show you a couple of examples so you can see it in action. So for the first example, let's try to use the ratio test to decide whether the sum of 1 over n times e to the n converges. And so to do this, we would look at the limit as n approaches infinity of what you get when you plug in n plus 1 divided by what you get when you plug in n, and with absolute values. And in this case, you have a fraction divided by a fraction, and so you can rewrite it as just a single fraction. And if you have absolute values in both the numerator and the denominator of a fraction, you can combine that into a single absolute value around the whole thing. And so this is where we are now, and usually with ratio test, you'll try to do some kind of cancellation to simplify things before actually taking the limit. And so in this case, you can cancel the e to the n in the numerator with e to the n in the denominator. And what you're left with is just 1 power of e in the denominator. And now we're in a position to take the limit, because the limit of n over n plus 1 is 1, and so then you're just left with 1 over e. And what's important for us is that 1 over e is less than 1. And so, according to the ratio test, the series converges. All right, so here's another example. Does the sum of 1 over n squared converge? Now, you already know that the answer to this question is yes. You can use the integral test on this. But let's look at what happens if we try to use the ratio test. So if we just write out the limit that's in the ratio test, this is what it looks like. And then, similar to what happened before, we can rewrite it as a single fraction where you have the n squared on top and the n plus 1 squared on the bottom. And now this is a fraction that has a polynomial on top and polynomial on bottom. And if you just look at the leading terms, you have 1 times n squared on top and 1 times n squared on bottom. And so the limit is 1. And so that means that we're in the situation where the ratio test doesn't tell us anything. And so in this situation, you would want to try something else. And like I said earlier, the integral test is a better option. So one of the things that happens with enough experience is you start to recognize which types of series the ratio test is good for and which type it isn't. But that's something that'll come over time. You can't expect it to happen immediately. All right, so why does the ratio test work? Well, a detailed proof would be a little bit technical, but the basic idea is that if we know that this limit of the absolute value of an plus 1 over the absolute value of an is equal to L, then the series where you take the absolute values of the an's and you sum those up looks like the geometric series, the sum of L to the n. And what I mean by that is that the geometric series, sum of L to the n, is the series where the ratio of the consecutive terms is exactly L. And so when we apply the ratio test and we get this limit L, what that's telling us is that, okay, the sum of an might not be exactly a geometric series, but it becomes more and more like a geometric series as n goes to infinity. Now, if L is less than 1, then we know the geometric series converges. And so then from that, you can show that the sum of the absolute value of an converges, because it sort of looks like the geometric series. And technically what happens here is you use a comparison test. And then there's a general fact, which is that if the sum of the absolute value of an converges, then the sum of an converges. And so this gives you that part of the ratio test. And then on the other hand, if L is greater than 1, that actually means that every term in the series is bigger than the term before it. And so that means that the terms are getting bigger, they're not going to 0, it can't possibly converge. So that's actually the test for divergence. Okay, so I know I skipped a lot of details here, but I just wanted you to have at least a rough idea of where the ratio test comes from. So I want to show you one more example because there are some calculations that come up in ratio test problems that you might not have done before. So let's say we want to determine whether the sum of 2 to the n over n factorial converges. Well, if we're using the ratio test, then we want to look at the ratio that's here. And as with the other examples, you can rewrite this as a single fraction with just a single absolute value sign. And now there is some cancellation that can happen. You can cancel a 2 to the n on top and bottom, and that leaves you with just one factor of 2 on top. And then you can also cancel the factorials. And just so you can see exactly what's going on here, I've got a little side calculation with just the factorials. So n factorial means that you multiply all of the numbers up to n. And n plus 1 factorial means that you multiply all of the numbers all the way up to n plus 1. And so when you have them in a fraction like this, you can cancel all of the numbers all the way up to n, and you're just left with 1 over n plus 1. And so when you put that calculation into the limit, then you just get 2 over n plus 1. And as n goes to infinity, that goes to 0. So the L in this case is 0, which is less than 1, and so according to the ratio test, this series converges. And I guess that's it. Hey Kailash, you want to tell a joke?
I want to play hide and seek.